Right now, off the coast of Florida, a disorganized cluster of thunderstorms is drifting toward the state with only a 20% chance of ever earning an official name, and by most measures, it will be gone within days. Florida meteorologist Matt Devitt summed up the system about as plainly as a forecaster can, posting that, at a minimum, this will be a rainmaker for Florida. Dangerous. Rip currents are expected along the coasts of Florida, Georgia, and the Carolinas, regardless of whether the system ever organizes, and if it does happen to reach tropical storm strength, it would become Bertha, the second-named storm of this year's Atlantic season. In a normal week, that would be the whole story, a modest rain event moving through, dropping a few inches of water and drifting back out to sea within a matter of days. This is not a normal week, because behind this passing system sits a forecast detail that has hurricane researchers at Colorado State University using genuinely striking language to describe it. According to their most recent outlook, wind shear across the Atlantic's main hurricane development region is forecast to reach the highest level recorded in over 4 decades of hindcast and forecast data, stretching back to 1981. That should sound like reassuring news, and in one narrow sense, it is. But the researchers publishing that number are not treating it as an all clear, and by the end of this video, you will understand exactly why. No hype, no exaggeration, just what the data from Colorado State University, NOAA, and the researchers actually building these forecasts are saying. If you live anywhere along the Gulf Coast or the Atlantic seaboard, drop a comment and tell me how closely you're watching this hurricane season so far. I read every one of these. If you want grounded storm coverage instead of panic headlines, subscribe. It is free, and a like helps this reach people before the next system organizes. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. Let us start with what is actually happening in Florida this week, since it is the concrete, immediate part of this story before we get to the bigger pattern behind it. The National Hurricane Center currently gives this disturbance a 0% chance of developing within the next 48 hours, and roughly a 20% chance over the next 7 days, a genuinely low probability by any standard. AccuWeather's lead. Hurricane expert Alex De Silva described it plainly, saying the chance of a tropical depression or storm forming in this particular area is considered low, but that this system probably represents the best chance for any tropical development anywhere in the Atlantic basin before the end of July. Regardless of whether it ever earns Bertha's name, rainfall is expected to be the biggest threat either way, according to De Silva, with widespread totals capable of producing localized flooding across parts of the state. Saharan dust and strong wind shear are the 2 specific ingredients forecasters have pointed to as the reason this particular system, and most of the disturbances that have tried to organize in the Atlantic so far this month, have struggled to develop any real internal structure, the same broad suppression pattern described throughout the rest of this video playing out in miniature on a single, unnamed system. This is a familiar pattern by now, the same one that played out when Tropical Storm Arthur, this season's first named storm, brought flooding rainfall across Texas, Louisiana, and Georgia back in mid-June before dissipating. A storm's rainfall risk and its official development status are simply not the same thing, and this week's system in Florida is yet another reminder of that distinction. So why are hurricane researchers using words like extreme to describe a season that, on paper, looks unusually quiet? The answer starts with El Nino, the same Pacific Ocean warming pattern that has driven nearly every extreme weather story covered on this channel this summer. Colorado State University's most recent forecast, released earlier this month, explains the mechanism directly. A moderate to strong El Nino is expected to dominate tropical circulation during the peak of this year's Atlantic hurricane season from August through October, and that pattern is forecast to drive well above normal levels of vertical wind shear, the disruptive change in wind speed and direction with height that tears apart a storm structure before it can organize. According to the university's own modeling, that wind shear across the Atlantic's main development region, the stretch of ocean between Africa and the Caribbean, where most of the season's strongest, longest-lived hurricanes typically originate, is forecast to be the highest recorded across the entire 1981 through 2025. Hindcast and forecast period the researchers use for comparison. Based on that signal, Colorado State University has projected this year's overall tropical cyclone activity at somewhere between 55 and 60% of the long-term average, an outlook the researchers actually revised downward from their earlier April forecast, specifically because their confidence in a moderate to strong El Nino reaching its peak has grown since then. The researchers behind this forecast, a program originally built by the late Dr. William Gray and continued by his colleagues for decades since, rely on a set of statistical predictors tracking ocean temperatures and wind patterns months in advance, and every one of the 4 major predictors they tracked this year pointed toward The same suppressed outcome, a rare level of agreement across entirely separate lines of evidence. Here's the part worth sitting with directly, because it is the honest reason this story is not simply good news dressed up as a warning for views. A below-average season, even a genuinely, historically suppressed one, has never meant a season without real, damaging landfalls. And the researchers building these forecasts have been explicit about that distinction, rather than letting the headline number speak for itself. Analysis of past El Nino hurricane seasons with a similar setup found that none of 7 comparable analog years produced more than a single United States hurricane landfall, a genuinely reassuring statistic on its own. But those same analysts have also pointed out that past strong El Nino seasons have still produced individually destructive hurricanes and tropical storms making landfall in the United States, meaning fewer storms overall has never translated into zero risk for the handful of storms that do eventually break through the suppression and organize. This is precisely the same tension that has defined nearly every tropical system covered on this channel so far this year. A quieter season on paper is not the same thing as a safer season for the specific community standing in whichever storm does eventually form. There is a deeper reason meteorologists are watching this particular setup closely, and it connects directly back to a mechanism this channel has already walked through in detail. Researchers tracking this year's El Nino have noted something genuinely unusual sitting beneath the ocean surface in the eastern and central tropical Pacific. Heat, roughly 2 degrees Celsius, warmer than typical for this point in the cycle, a signal strong enough that several forecast models, including the European Center for Medium-Range Weather Forecasts, are now projecting a near-record strength El Nino event for later this year. One risk analyst who studies these patterns closely described the reasoning behind that projection plainly, explaining that the sheer amount of heat sitting beneath the ocean surface right now is one of the clearest signals researchers monitor, precisely because it represents energy that has not yet fully surfaced into the atmosphere. Energy the ocean is essentially still holding in reserve. That same reservoir of unusually warm ocean, water is not confined neatly to the Pacific. Warm water anomalies have already been documented spreading across the western tropical Atlantic this year as well, even as the central and eastern tropical Atlantic runs slightly cooler than average, a genuinely mixed signal that researchers say partially offsets some of the storm-suppressing effect of the wind shear described earlier. In other words, the same overall climate pattern, currently tearing apart most storms before they can organize, is also quietly stockpiling an enormous reservoir of ocean heat in specific pockets of the basin. Heat that has nowhere to go and does not simply disappear because a given storm failed to form around it this particular week. This is exactly the combination that should sound familiar if you have been following this channel's coverage of Hurricane Otis, the 2023 storm that intensified by more than 100 miles per hour in a single day and remains one of the most dramatic forecasting failures in modern hurricane history. Otis formed during an El Nino year. Researchers who studied it afterward noted that the pattern likely played a genuine role in warming the eastern Pacific and favoring exactly the kind of rising, moisture-laden air that fueled its explosive strengthening. A hurricane season defined by extreme wind shear does not eliminate that risk, it concentrates it. Most disturbances this year will get torn apart before they ever have the chance to organize, exactly as this week saw one Florida system likely will. But the rare system that does manage to find a brief window of lower shear in a basin sitting on top of unusually warm, unusually deep pools of ocean heat inherits every one of the ingredients that produced Otis in the first place, concentrated into a smaller number of opportunities rather than spread out across a normal busier season. Think of it less like a season with the danger turned down and more like a season with the danger compressed into fewer windows, each one carrying a disproportionate share of whatever risk the entire season would ordinarily spread out across a dozen or more separate storms. NOAA's own institutional behavior reflects this same underlying uncertainty, and it is worth noting directly rather than assuming forecasters are simply confident in the quiet numbers they published back in May. When NOAA released its official 2026 Atlantic Outlook, forecasting a 55% chance of a below-normal season with somewhere between 8 and 14 named storms, 3 to 6 of them hurricanes. The agency also announced it would issue a fully updated outlook in early August, deliberately timed to arrive just ahead of the season's historical peak, which typically runs from mid-August through October and centers most heavily around September. Forecasters do not build a scheduled mid-season reassessment into their public communications because they are fully confident nothing will change between May and August. They build it in because El Nino's strength, the exact wind shear pattern it produces, and the underlying ocean heat available to any storm that does organize are all still evolving in real time. And the honest, current picture in July is not guaranteed to be the same picture by the time peak season actually arrives. NOAA has also rolled out several changes to how it communicates risk this year specifically, including updates designed to better convey danger that extends well beyond the coastline itself, since flooding, tornadoes, and damaging winds routinely continue to threaten communities long after a storm has technically made landfall and moved inland. There is a genuinely important lesson in how last year's hurricane season actually unfolded, and it is worth carrying into how you read this year's numbers specifically. Colorado State University's own August update last year noted that despite unusually strong wind, shear across the Caribbean through the first 2 months of the season, warming tropical waters, and a favorable pattern in the atmosphere over Africa meant that, in the researchers' own words, things were really picking up by early August, even after a slow, quiet start that had not truly gotten going until late September the year before that. The lead researcher behind that forecast described the shift directly at the time, noting that the tropical waves coming off Africa closer to the season's peak looked noticeably stronger than they had earlier in the summer, the exact seeds that eventually grow into the season's most significant hurricanes once they cross into warmer, less hostile water. A slow beginning to a hurricane season is not the same thing as a guaranteed quiet ending, and the researchers who study these patterns for a living have been careful, year after year, not to let an early season lull get mistaken for a full season promise, regardless of how comforting that early lull might feel to anyone watching the numbers from the outside. So what does all of this actually mean for you? Whether you are watching a small, disorganized system drift past Florida this week, or simply keeping half an eye on hurricane season from somewhere further inland, it does not mean you should treat every low percentage disturbance as an imminent catastrophe. And this week's Florida system genuinely does look, by every available measure, like a rain event rather than a major storm. What it does mean is that a below-average season, even one hurricane researchers describe using words like extreme to characterize its wind shear, IS, not a season worth tuning out of entirely, particularly heading into August, when NOAA's own updated outlook arrives, and when the historical peak of hurricane season genuinely begins. The practical takeaway is simple and unglamorous. Keep a hurricane kit ready, regardless of how quiet the season sounds in the headlines. Pay attention when NOAA issues its August update rather than assuming the May forecast is the final word for the entire year. And remember that the same forces suppressing this year's storm count are, at the same time, loading specific pockets of ocean with exactly the kind of heat that has, in other recent years, produced some of the most dangerous, least predictable individual storms on record. If you live along the Gulf Coast or the Atlantic seaboard, this is also a reasonable moment. While the season is still quiet, to actually locate your household's evacuation route and confirm your insurance coverage, since both are considerably easier tasks to complete calmly in July than in the middle of an active watch once a storm has already organized off the coast. The honest, grounded summary of this story is this. A disorganized system drifting toward Florida this week carries only a 20% chance of formal development, and its primary threat, regardless of whether it ever earns the name Bertha, is heavy rainfall and dangerous rip currents rather than a major hurricane, echoing almost exactly the pattern set earlier this season by Tropical Storm Arthur. Behind that modest passing system sits a much larger signal, a moderate to strong El Nino forecast, to drive wind shear across the Atlantic's main development region to its highest level in more than 4 decades of comparable data, suppressing this year's overall storm activity to an estimated 55 to 60% of the long-term average. That suppression is real, and it is backed by real, carefully built statistical forecasting rather than guesswork. But researchers have been explicit that suppression has never guaranteed a landfall-free season in comparable historical years, and the same will das Scientists. Nino driving that suppression is simultaneously helping stockpile unusually warm ocean water in specific pockets of the basin, the same underlying ingredient behind Hurricane Otis's infamous, still not fully explained explosive intensification in 2023. NOAA's decision to schedule a fully updated outlook for early August, deliberately timed just ahead of the season's historical peak, reflects the same honest uncertainty driving this entire story. A quiet season on paper that the very researchers describing it as quiet are not yet ready to call safe, and a pattern that last year proved capable of shifting from a slow start into a genuinely active stretch within a matter of weeks, once conditions in the atmosphere finally lined up. We are going to keep tracking this pattern as peak season approaches, sourced the same way we did today, straight from Colorado. State University, NOAA, and the researchers actually building these seasonal outlooks, not recycled headlines dressed up as breaking news. Subscribe so you do not miss it when NOAA's August update arrives, because based on how much can shift between now and the season's historical peak, that update is genuinely worth watching for. And leave that comment below. Tell me whether a quiet season forecast makes you more relaxed about hurricane season or more suspicious of it. Because behind every one of these seasonal outlooks is a family in Florida checking their rain gutters before a storm that will probably never even earn a name, a researcher at Colorado State University watching a wind shear number climb to a level nobody in their dataset has ever recorded. Before, in a pocket of unusually warm ocean water sitting quietly in the Atlantic, waiting for the one narrow window this suppressed season eventually gives it, 5,000 likes on this one. Let us go. See you in the next one.